Welcome back, everybody. We're going to work through the surface area of a right rectangular prism note. It is also a surface area of an open box on the back. So we're just going to work through these together so you guys can have some extra examples to help you along with what you're doing. So on our grid, we're going to draw a net. Remember, that's if we were to open up our three-dimensional figure and lay it flat, what would it look like? So we're going to draw a net of our prism, and we're going to find our surface area. Each square on our grid is going to be 1 square meter. So I'm going to start off doing, I'm just going to start off right here on the top. And we've got 1 square that goes, let's see, we'll start right here. 1, 2, 3. And then it goes 5 across. So we go 1, 2, 3, 4, 5. So now we're going to make our rectangle because we have a rectangular prism. So all of our faces and bases will be rectangular. Then we have another one that is only 2 by 5. So see, you have 3 by 5 on the bottom here, and then you have a 2 by 5. So then you have 1, 2. Now remember, we're going to have 2 of those sides that look exactly the same. So you have 1, 2, 3 again. And then 1, 2. So that takes care of all of our faces of our rectangular prism. Now our bases are 3 by 2. So we're going to go 1, 2, and then 1, 2, 3, and connect. That takes care of 1. And then 1, 2, 1, 2, 3, and connect. So in order to find your surface area, you can find the area of each one of these rectangles and then add them together, and that will give you your total surface area. Or you could find that you could sit here and actually count all of the little boxes. Well, this one is 3 by 5, so this one is going to be 15. So that means this one's going to be 15 because they're the same. This one is 2 by 5, so this one's going to be 10, and this one's going to be 10. This one is 2 by 3. See, this is 2, this is 3, so this is 6, and this is 6. All together, our surface area is, let's see, 15, 30, 40, 50, 62. And then we're going to say these are square meters. I'm going to abbreviate instead of writing it out, because they said each one of our squares represents 1 square meter. So, after drawing the net, explain your method for finding the surface area of the prism. Depending on how you did it, you may have actually counted all the squares, or you may have actually found the area of each rectangle, which is what I did. Found the area of each rectangle. Then added them together. Okay, what other method? The other method that I would say would be to just count the squares. Count all of the squares. Okay, so on here it says, draw the net on a grid with larger squares, cut it out, and make a model of the right rectangular prism in this activity. Don't worry about doing that. Due to spring break coming up, we guys have a checkpoint on Thursday, and we're running out of time. We're not going to do this. If we end up getting some extra time towards the end of our unit, then maybe we'll go back and do some activities like this. But for right now, just don't worry about it. It's not a big deal. Okay, so let's flip it over. It says, Sam is designing an open wooden box in the shape of a rectangular prism. The base of the box will be 6 feet by 8 feet. He has not yet decided what the heights will be. Draw a net of this prism below and label the dimensions of each polygon using the net. Remember, the box does not have a top. Okay, so we're only going to have this side that's right here, the bottom, and then the far side. We're not going to have the matching top piece. So instead of having 2 that are 8 by 6, like this one here, let me shade that so you can see the base. Instead of having 2 of those, because they would be across from each other, we're only going to have 1 because we have no top. So this time, we're actually going to have I'm gonna do our bottom piece in the middle. So this one is going to be the one that is 6 by 8. So this is 8. This is 6. So then we don't know a height. We're just really not sure. He said he didn't know how tall he was going to make it. So we can make these what we want. This would be 6, and this would be our height because we don't know what it is. Same thing here. We don't know how tall this is going to be. So we're just going to write H instead of height. And then this one's still going to be 8. Over here we have our matching end piece to the one on the right. Still 6 wide. We do not know a height. And then this is our other matching side piece. This is going to be 8. And this is going to be H. Because we don't know a height. We're not really sure. So it says use the net to write an expression representing the surface area of the open box. So we're just kind of listing it all out. What are we going to add up? Well, we've got 6 times H plus 8 times H. That takes care of this one and then this one. Plus we've got another 6 times H plus another 8 times H plus our one in the middle, which is 6 times 8. That works perfectly fine. That gets the job done. That covers everything we need. You could also combine some of your stuff. You could do one that looks like 2 times 6H, because we have 2 of those, plus 2 times 8H, plus 48, because we have 6 times 8. Oops. That's just right there. Plus 48. That's another way to do it. Or you could even combine this even more. 2 times 6 is going to be 12, so we have 12H, plus 2 times 8 is 16. Well, 12H plus 16H, God, I can't talk it so much. See, 12H plus 16, 6 plus 2 is 8, 2 plus 2, 2 plus 2, what am I talking about? 1 plus 1 is 2, so then you could also do 28H plus 48. So there's a bunch of different options, whether you want to expand it all out and have every piece on its own, or you could combine your ones that have 6 times height and the ones that have 8 times height, or you could just combine it all together. So any of these options would work just as well. They all say the same thing. Just one is more condensed and the others are more expanded. So it says, use the expression to determine the surface area of the open box if Sam makes the box 4 feet high. So in order to make my life easier, I'm going to use this one so I don't have to do as much math. So all we would have to do is 28 times 4 plus 48. All we're doing is substituting it in. So this is actually going to equal 160 square feet. It says Sam will paint only the outside of the box. He has enough paint to cover 150 square feet. Does he have enough paint? Explain your answer. Let's see here. If he makes the box 4 feet high, let me write this in. If he makes, God, my paper keeps moving. The box 4 feet high, he will need to paint 160 square feet. So if he makes a box 4 feet high, he will not, in capitals, will not have enough paint. He would need 160 square feet, not 150. Close, but not quite. Okay, last one. If Sam does not paint the bottom of the box, does he have enough paint to cover the 4 sides? Explain your answer. Well, we found our base to be 48, so we could do 160 minus 48. That's going to give us 112. Oh, I could put no right there. So, yes, he will have enough paint because he will only need to paint 112. And you can explain that out in words. I don't need to write that for you. So if you have any questions on this, please let me know. This is just a notes page for you to help you through everything that we're doing in this unit. If you have any questions, let me know. You can also request a workshop. Thanks.